guys, today I wanted to introduce to you something that also kind of falls into the category of Newton's second law, which is speed, velocity, and acceleration. We've all heard of speed, so that's going to be not so hard. Really, none of them are hard if you understand what the differences are. And your TEK states that you need to be able to differentiate or know the difference between speed, velocity, and acceleration. So let's get started. Alright, we all know speed. We know a speed limit. We know that if we're driving a car, the speed is shown in mph, which is miles per hour. So that shows us that we do speed and speed calculations all the time. Speed is just a measurement of how far you travel in a certain amount of time. So you go a certain distance and the time involved, that gives you this measurement we call speed. Now for our purposes, we are calculating basically average speed. So the formula we use, and you can check your formula chart that you printed out a couple days ago, or if you don't have it, write it down. Speed is equal to the distance traveled divided by the time involved. However far you go, then you divide it by how long it took you to get there, and you get your average speed. Now we're going to do an example. So you see at the top the formula, speed is equal to, the D stands for distance, divided by time. Okay, so for example, if you drive 300 miles in 3 hours, what's your speed? Well, so you take the formula, put 300 miles divided by 3 hours, and you're going to come up with the answer of 100 miles per hour, right? Because it was miles and hours. You can write it out miles per hour. Most of us just abbreviate it mph for miles per hour. Distance of speed can be measured in a variety of ways. It might be measured in miles, kilometers, meters, centimeters, but distance, units of distance are all there. Time can be measured in hours, minutes, seconds, days, years, months, whatever you do. It's got to be a time unit. So the most common speed units that we'll be using is miles per hour, kilometers per hour, or meters per second. Remember, for these calculations, you can use your calculators as well. So here's how you would set up your formula triangle. Remember, anything that's divided in the formula, which is distance and time, you put the D you would put at the top of the triangle, because on the right side it shows a little division arrow between top and bottom. Time you would put on the bottom, and then the remaining square you would fill in with the S for speed. Formula triangle, once again, allows you to manipulate formulas. So if you have to calculate distance or time, it shows you, by covering up the one you're missing, shows you what to do, divide or multiply. Alright, so let's practice. So it has a speedboat going 50 miles per hour over 5 hours. Now we're calculating this time for how far. So we're calculating for distance. So if you put it in your formula chart correctly, you would have gotten 10 miles as an answer. So make sure you practice and manipulate your formula triangle, or if you want to manipulate the formula for algebra students, that's fine. But just make sure you're coming up with these answers as you go through and try to calculate speed. Okay, a dragster drives 75 yards in 7 seconds. So here we have yards for distance and seconds for our speed. So 75 divided by 5, and you should have gotten the answer, hey guys, 15 yards per second. Sorry, my dogs are wreaking havoc. Shh, stop. Stop. Alright, so Miss Kidder drives to see her daughter in Louisiana. She drives 270 miles in 3 hours. What is her speed? Her speed is 90 miles per hour. And yeah, that's about right. Alright, so what is velocity? What is velocity compared to speed? Lucky, stop. All right, speed is how fast you're traveling, right? Oh, and compared to your time, so the car is traveling at a speed of, for example, 20 meters per second. But velocity has two parts, so it's speed and direction. So you're going to get the speed. Let's say I'm traveling north, so I was traveling 25 miles per hour north, or 25 miles per hour up, down, sideways. Anytime you have your speed and direction, you have velocity. Hang on, guys, I'm talking to my dogs. Alright, that's much better. Okay, so velocity is speed in a given direction. So you'll always have a direction included when you have velocity. So if you look at the example here, it says the car is traveling at a velocity of 20 meters per second east. That's the direction east. So, remember two things. Velocity is speed and direction. Another example is 20 miles per hour straight. It could be 5 miles per hour up, down, sideways, straight, north, south, east, west. All of those are examples of Okay, so here's another example. The skydiver is falling at a speed of 165 meters per second. Well, what's his velocity? Well, his speed is 165 meters per second, that's speed, plus his direction is what? What's he falling? Up, down, sideways? I hope you said downward, or down. Alright, so here, the next one we're going to look at is what's known as acceleration. Acceleration is a change in speed, a change in direction, or a change of both of those. So if I am speeding up, slowing down, coming to a stop, turning the corner, all of those would be an example of acceleration. So when people talk about acceleration, they usually think of speeding up, but that's not actually accurate. Acceleration is any change in speed, or any change in direction, or both of those. So anytime something's slowing down, speeding up, coming to a stop, starting, that's going to be your change in speed. Change in direction could be turning the corner, going in the curve, driving around the block, any one of those. So, once again, acceleration is a change in speed, so you speed up, slow down, start or stop moving, or a change in direction, right, left, front, back, or going in the curve, or both. A change in speed and direction indicates acceleration. Here's an example. In this one it says 3 vehicles shown below are traveling at the speed of 15 meters per second, but only one of the pickups has a changing velocity. If they're all traveling at the same speed, 2 of them are going straight and no change in velocity, but one of them, which one is changing direction? That would be the pickup truck, because the pickup truck is turning the. Alright, here's some more practices for star warm-ups. You can do them. It's just a matter of different examples of using your force, motion, acceleration, or net forces. So any of these